This is Algebra 1, Lesson 15, Surface Area, and Example 1. We're going to be talking about geometric solids. What are those? Let's look at some pictures and then we'll talk about these terms. Here's some pictures of geometric solids. You may have seen some of these maybe when you were little and you played with some blocks, and some of your blocks look like these, possibly. Or here's just a ball. A basketball. Now you can notice that these are drawn to be three-dimensional. They didn't just draw a circle, a two-dimensional circle on the paper. They drew this little dotted line to try to represent that there's some depth to it, that this is a three-dimensional drawing of a figure on a flat surface. So these are all 3D things and they're geometric solids, shown that they have some length, some width, some height to them. Now I went ahead and made a Venn diagram. If you've seen a couple of my videos, you know that I like Venn diagrams to organize information. So we're going to look at some of the vocabulary terms that they give you in this lesson in this Venn diagram. So the black circle represents geometric solids that we just looked at, and they each have different names, and we'll talk about those. And then there's a blue circle for right geometric solids. And the textbook explains that right geometric solids would be these figures who have 90-degree angles in them. Okay, so it's going to be figures like this. See how the sides there? It's a rectangle that meets another rectangle, so you can imagine there's a corner, there's a 90-degree angle there, and all of these corners are 90 degrees. So that is a right geometric solid. In fact, let's just go ahead and move it into this circle here to show that yes, it is a geometric solid, but more specifically, it's a right geometric solid. Let's see what else. Well, this one would not be, because you do not see that it has right angles in it. This one would not be. This one here, you can see not a right angle. But this one that looks like a cube, I would say that's a right geometric solid. And then here, this is a cylinder. It has a 90-degree angle. The side meets the base at a 90-degree angle. It's not leaning over. Okay, and that's a cylinder. Now let's talk about the bases. I use that word base. The bases are going to be the top and the bottom, what we would normally call. They're going to be identical geometric figures, and they're going to be opposite of each other. Okay, so let's zoom in here. This is called a rectangular prism. I'm going to color in the top and the matching bottom. They're both rectangles. They are equivalent to each other in their dimensions and in their area, and they are opposite of each other. Okay, you could call these two the bases if you would like. Okay, or you could call the front and the back. There's the front, and then here's the back, if you're imagining it's kind of seeing through or on the other side of it. So those are bases. Here you could call this top and bottom, left and right, front and back, any of those as your bases. With the cylinder, you would call the top circle and the bottom circle the bases. Now, from our perspective, it looks almost like an oval, but it is a circle, just looks different because of our perspective. Okay, so to be a prism, you would have to have equal bases. If your bases they are equal, but then also they have to be polygons. Okay, now if you remember us talking about polygons, they are going to have straight sides. It's a closed figure with straight sides. Okay, so now we can make some more moves here. This rectangular prism, which I've already said is a rectangular prism, it is a geometric solid. It's a right geometric solid, and it's a prism. Okay, so more specifically, it is a prism. And this cube is also a prism. More specifically, a prism. Okay, it's also a rectangular prism, but if all the sides are equal, we call it a cube. okay? And then that leaves the cylinder there in the right geometric solids. There are others, but just for the ones that I picked, it's the only one. Now, these geometric solids, they're not right, and they're not prisms, but they are geometric solids. So let me back out here, and you can see how we sorted those. So when the book gives you these terms, we've talked about geometric solids. They're all examples of that, 3D figures. Right geometric solids are going to meet at a 90-degree angle. We talked about the bases and looked at some of those. We talked about what a right prism is. We know that these prisms are right, okay, because they meet at 90-degree angles. And a prism is going to be that base, like if you were to cut it, let's talk about that for a second. If you were to cut this rectangular prism, just make a slice down through here, and you cut out, imagine this being like butter, okay? If you cut out this slice, it's going to be the same as this base, okay? You're going to get a square or a rectangle if you slice it, okay? And if you played with Play-Doh, you've probably done that before, sliced it up. If you were to slice this cone, you wouldn't get the same thing throughout it, would you? So that's another thing you can look at is slices, and we'll learn more about that later. Surface area was the last term that they talked about in this lesson, and we've done area. You know, you could have found an area before. We did some rectangles and some triangles and all sorts of two-dimensional figures, right? So what we're going to do now is figure out what would the area be for the whole outside of the figure. So like if I have a box like this and I want to wrap it, I want the top, the bottom, because the bottom will be showing. I want the right side, I want the left side, I want the back, and I want the front. All covered in wrapping paper. I need to know surface area for that. So we're not talking about filling the box with anything. We're talking about covering the box with something. And you know, for us, it might be wrapping paper. But if you're a manufacturer and you're building that box, you need to know how much cardboard you need for that box, plus some overlapping area, right? So let's do an example. And for this lesson, I'm going to do a separate video for each example because they are kind of long. So we're going to do each one of these examples as a separate video. So I'm going to stop here and we'll pick this one up on the next video.